This is exercise 11 of chapter 2. I chose this exercise because it was listed in the list of exercises that are going to help us prepare for our practice test. By the way, it is September 21st, 2020. So I'm going to do a couple of these, but I want to talk about how to do them before we actually, like what the basic steps are for each problem. So it first says over here, rewrite the following argument into symbolic form and then use a truth table to determine if the argument is valid or invalid. So the first thing that we're going to need to do is we're going to need to rewrite this argument in symbolic form. So symbolic form for us is going to mean that you're allowed letters. So you're allowed things like P, you're allowed things like Q, and these things are all going to equal some sort of sentence. And that sentence that they all equal, like P can equal something, Q can equal something, those sentences, this will be sentence 1, sentence 2, are going to be portions of this full sentence. Then in addition, you're allowed to use and, not, if, then, or. You could probably use the biconditional as well. And you need to read this, and certain words are going to be trigger words for these symbols. And if they're not trigger words for these symbols, then you plop them into these kind of open sections. So I'll show you what I mean. So if and then go together. And that is the implication arrow. So I know that for sure I'm going to have, when I try and rewrite this argument as symbolic form, I know for sure I'm going to have an implication arrow because of the if then. So just for the first go here, I'm going to kind of show you what's happening here. So this is from this. And then over here, tufa floats. So it's like the thing that comes after the word if generally goes on the left side of the arrow. So if tufa floats. Now tufa floats has nothing to do with these symbols over here. So I'm going to need to label tufa floats as a propositional variable. Now a lot of people might assume, why would you say that tufa floats is P? So like, why not just tufa is P and then we could say that Q is floats? Well, this would be wrong because each variable that you label, so each sentence that you create, it has to be something that you can answer true or false to. So if I say tufa floats, you could be like, yes, tufa floats, or no, tufa floats. But if I were to be like, floats, you can't really say yes or no. It doesn't make sense. But if I were to say, does tufa float, you can say yes or no. So that gives me an indicator that I want to put both of these as my P. Then is captured here. It's like those two words are in the orange arrow. Some rocks float. Okay, so the word some is not actually captured in any of these. It does seem kind of like a logical word, kind of like a quantifier in a way, like some, but don't let that confuse you because all we have is and, not, if, then, or, and if and only if. So what we're going to have to do is we're going to have to make some rocks float as an entire other sentence. So I'm going to go over here, go Q and say some rocks float. Okay, nice. Now, I'm looking over here, tufa floats. We already defined that, so I'm going to highlight that like this in the same red as before, so tufa floats. Whenever you see the word therefore in these exercises, it means that big boy arrow, okay? But first off, actually, it was if tufa floats, then some rocks float. So the tufa floats was P because I labeled it here, so it's going to go in front of the arrow. And then whatever comes after then comes after the arrow. So that would be the some rocks float. Then also we have a period. So that in my head just means like go underneath this because you have to make a new premise or a new sentence in its entirety. So the next thing would be tufa floats. That's literally just P. And then you have therefore, so this is going to be your conclusion. I like to do this little symbol for therefore so that I understand that whatever's after that, that's the mathematical symbol for therefore. So like whatever's after that, I know that's what I'm trying to like prove based on these guys. Some rocks float. Didn't I already define that? I think I did. I defined it as, yeah, Q. Okay, cool. So here's P, and then here is Q. I don't have to color code everything always, but it definitely helps if you're new to this. And then here's P. So it's therefore, therefore some rocks float. Okay, so Q. All right. So now that I have these, then that would be like the first step to do for each of these. Just try and get like each sentence. So there's one sentence here, second one is Tufa floats. Try and get each sentence into like, this is my first premise right here. One, oops, sorry, colors are hard. 1, 2, and then my conclusion. So I have my first sentence here, and then my second sentence, and then I have my therefore, which is like this guy, and then my conclusion, which is some rocks float. Now from here, people say, well, how do I like transfer both of these sentences along with the conclusion into a truth table? Because that's how you're going to check its validity. It says use a truth table to determine if it's valid or not. So I'm going to get rid of this. What you're going to do is, this is super important. I found this in like, I think section 2.8 of your book. And this is how you want to set up your stuff in the truth table. This is how your professor defines kind of hunting for validity within a truth table. You have to join all of your premises, like premise 1, premise 2, up to premise n. That could mean that you have like 5 or 6 premises. He's just generally stating however many you have to be joined by the and symbol. And then this is like that. And then you have your conclusion, which in my case is just Q. So when you make your truth table, you can join all of your premises together with these little and boys. So I'm going to show you what a general truth table looks like, and there's definitely different ways of explaining this. This is the way that I like to do it. So what I always do actually is I used to like take a highlighter and I would highlight down like this. And then on the left side of this on my truth tables, I would just like list all of my basic baby letters, like my P and my Q. And then on the right side, I would list all of my premises and my conclusion. So over here, I'm going to try and construct this based on what I have so far. So my first premise here, premise 1, is P then Q. So I'll put that in brackets. You generally want to put each individual premise in brackets. And then I need to put this and. So I'm going to put and then premise 2 is just P. Then, once you're done that, what I like to do is, because I've done all my premises, put them all in like big brackets. So like this, cool. And then this guy, according to your textbook, you're allowed to just do this. Now, if he asks you if these two things are the same thing, the answer is no. One of them is a logical connective and one of them is more of a meta-language symbol. But for these purposes, in terms of like getting the truth table correctly, it doesn't matter. You can like this is this in this context, but not in terms of definition, okay? So you're free to replace this with this every single time, and then you have your conclusion, which in my case is just Q. So this is how I set my stuff up. Then you should hopefully be familiar with how to set up your T's and F's. So T, F, T, F, cool. Okay. Now, I'm one of the compact people, so I noticed that in your book, you can do this in like a compact way and then in a non-compact way. I'm going to teach the compact way because that's how I was taught, and I think it's easier. And I'll also be better at explaining it for sure. So, just like with math, you have to kind of start from the inside out. So I'm going to start by trying to figure out the truth values of this guy because he's the most bracketed person out of all of these things. You don't have to do this, but what I tell some students to do when they start studying truth tables is you see this P over here? Actually, okay, what you're going to do is try and think of it like, oh God, try and think of it like as if each row is its own universe. So like we're going to be dealing with the world in which P is true, so the world in which tufa floats and the world in which some rocks float, okay? This is the world that we're going to be dealing with, and we're not going to deal with this until a moment or so. So moving through here, we are dealing with a world in which tufa floats and some rocks float. So does the statement, the mini guy here, if P then Q stand true? Well, if tufa floats, then some rocks float. Tufa does float, some rocks do float, so then this statement, if tufa floats, then some rocks float, is true. I'm basically, like, what I'm doing in a way also is, like, I'm kind of, like, repeating, like, let me color these over in pink so that, because colors are really helpful. In my head, I'm like rewriting this T like here really small, and then I'm rewriting this T. Like my eyes are kind of darting like what's Q and like what's P, and I'm looking at them kind of underneath, and I'm like, okay, T to T with an arrow means true. And then over here, this P, well, we're in this world, right? So this P would be true, just like this one. So I have like a little T here. And then like to do this and, the and is the connector between this P and this big guy. And so I'm looking at a left side of this, which is overall true, and I'm looking at a right side of this. So it's like true and true. So then this would also be true. Then this Q over here, according to my little chart over here, is true, so I can kind of just like repeat it. The reason why some of these are in pink is because like I'm literally just rewriting whatever I see here over here, whereas what's in black is like me actually comparing two truth evaluations and like making a judgment based on like T to T with an arrow is like a new T, whereas this T is just a repeat of this T. So that's why I kind of wrote them smaller. Okay, now for the big arrow, is this big arrow true? Well, on this side of the arrow, we have a true, and then on this side, what is like the biggest? Is it going to be this one that represents the entire bracket, or is it going to be this one? Well, look at this. Like, this is one side of the and, this is the other side of the and. So this, whatever's under this represents the truth value for the entire thing. So it's like true to true with an arrow, that means that this thing is true, okay? And whatever comes under, like, whatever comes under this arrow is going to determine whether or not your argument is valid. So this is actually really important. When you go through all of these rows, if the whole thing is T, 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 then it's valid, okay? I can explain why perhaps in a later video, but yeah, if the whole thing is T, it's valid. If there's like one F in there, like if it's something like this, then what this indicates is that it's invalid because there exists a world in which the premises are true and the conclusion is false. That's what it would mean. But if that loses you, it's okay for now. I feel that right now I kind of want to just talk about the mechanics of this. Basically, again, you got to get T's down the line of this green blue guy, okay? So I'm going to do it a little bit faster now. Moving forward, okay. If P, then Q. Okay, so I'm having a T to an F. Like P is like T and Q is F. So that would actually be false because you can't have like a conditional true to false. That's false. So I put this here. This P over here is like true. I'm just kind of repeating it from here. So false and true is a big false. This guy, I'll just repeat it. It's true. And then false to true. Okay, that's fine. If you know your truth table for the conditional, then you'll know that a false to a true is actually fine. And then over here, P to Q, so that's false to true. That would be true. My P over here is false. So this is false because it's a conjunction, right? So it's like true and false. So then the whole thing is false. Over here, I have a little baby T because Q is this guy. And then false to true is true. It's true. You got to know your implication truth table. Now down here, if P then Q, I have false to false. That's okay. And then P is little baby false right there. So then this would be like a big false because you can, like true and false. See, like true and false. And then here is Q, so he's going to be a little baby false. I'm just copying it from here. And then we have false to false, which is actually fine. So I have T's going down the middle. That means that this argument is valid.